to go through the test and I'm going to go through the marking, and if you have any questions, obviously let me know, but I suppose the idea here being that you can spend as much time with these solutions as you need to, and if there is a question that you did really well and you don't need to be listening to me going through it, just fast forward me. And I also thought it might be handy when you're looking back and revising maybe at Christmas. Okay, so the number of bacteria in the early stages of a growing colony of bacteria, okay, can be approximated using this function, where t is the time. So I'm just going to highlight some of these. So t is the time. Oh, and it's going to be important that it's measured in hours since the colony started to grow. And nt is the number of bacteria. Okay, so find the number of bacteria in the colony after 4.5 hours. So 4.5 hours is a time. So I'm going to do the number of bacteria equals 450 e to the 0.065, and in place of t I'm going to put in 4.5. Just going to type that into my calculator. Multiplied by 450. So I'm getting 602.8977, and it does say correct to the nearest whole number, so 603 bacteria in the colony. Okay, so marks for that are here. So 603 is right. It's a good start. And you can see it's 10 marks in total, and the low partial credit goes with the low score. So the low partial credit in this question is 4, and some substitution into the function and a correct answer without showing work. So if you do it all in your calculator and just write down 603, then you can only get 4. High partial credit is for correct substitution. That's completely correct. They must have just done something like, as in if they, and by they I mean you, if a student fills in the 4.5 in the right place and then for some reason gets the answer wrong, or fills it in but doesn't actually press equals, those kind of things will get you 8 marks. Okay, right. Next. Oh no. Sorry, I've just noticed this question is an integration question. I was supposed to take it off and I didn't, so I do apologize. Okay, anyway, the one above is fine. Find the time in hours that it takes the colony to grow to 790 bacteria. Okay, so to grow to 790 bacteria, they've given us NT there, or N, and they've given us the left-hand side. So it's going to be 790 equals 450 e to the 450 e to the 0.065 t. I'm going to make sure I took that down right. 450 e to the 0.065 t. Yes. Okay. So we did a few of these in class. Divide across by 450 to cancel that and kind of isolate your e, sort of. So that gives us e to the 0.065 t equals 790 divided by 450 is 1.75 recurring. So just, I'm going to keep as many decimal places, so I'm going to keep the recurring. I can't solve this because the t is in the power. So if you can't solve an indice, you switch to logs. So I'll change colour and it's log to the base e. The answer becomes the argument, and then the 0.065 t, the power becomes the answer. Log e is the natural log, or ln, of 1.75 recurring, and that equals 0.065 t. Okay, so ln of that is, so that left hand side, I'm just going to move up, is 0.5627, and I have more places, but I'm going to hold them all, just holding them on my calculator. And that equals 0.065 t, and then I divide by 0.065, divide by 0.065. So I'm going to hold this whole number in my calculator. I'm simply pressing divide 0.065. So that gives me a t of 8.658. So it does say here, correct to 1 decimal place. So that is 8.7. And then we were told at the beginning that the time is in hours, weren't we? Yeah, the time is in hours. So that is 8.7 hours. Okay, so 10 marks again. Yeah, I think oh, they did it slightly different. Oh, no, they didn't. They just didn't sub in the 790. That's weird. Okay. I think my solution is a little bit more straightforward than that. But again, you have 4, 8, 10. So have a look at what you're getting for the low partial, have a look at what you're getting for the high partial, and see do your efforts. I suppose make sure I gave you the right marks is what I'm trying to say. Okay, so that is question 1, and question 1 is worth 20 marks. All right. Okay, question 2. So question 2, given that f of x is 3x squared plus 8x minus 3, where x is an element of real numbers, find the 2 roots of f of x equals 0. So find the 2 roots is the same as solve, which is, you've done a junior cert, and we did again for anyone who did TY, we did a good bit of that last year. So we take 3x squared plus 8x minus 35, and you either do, it's a trinomial, so you either do the guide number or the minus b formula. I'm going to do the guide. I don't know if it's going to work, but should we give it a go? So the guide is going to be 3 times minus 35. So the guide is going to be minus 105. So that's 1. 2 won't work. 3, oh, that's how I got it. So 3 times 35. 4 doesn't work. 5 is 21. Still not going to work. So I'm looking for a combo that will give me 8. Yeah? 105 divided by 6. No. 7. Yeah, 7. Ooh, 7 and 15. That'll work. I need a plus 8. So that means I need a plus 15 and a minus 7. So I'm going to go 3x squared minus 7x plus 15x minus 35, and I'm going to make my red bracket and my green bracket. So red, common factor is x, or 1x, if it helps with the division. So that gives me 3x minus 7. The green bracket is 5. That gives me, if I divide both of these by 5, I get 3x minus 7. I need to check if these brackets match, which they do. So that gives me 3x minus 7x plus 5. So there's my factors, and I wasn't asked to get factors. I was asked for f of x equals 0, and I was asked for the roots, which means I need to solve. So I get 3x minus 7 and let it equal 0, and x plus 5 and let it equal 0. So let's see. If I plus the 7 plus the 7, I get 3x equals 7, and then divide by 3, and x equals 7 over 3. And then this side, minus the 5, and x equals minus 5. Sorry, it's a little bit tight there. So that's what I'm getting, 7 over 3 and minus 5. Yep. So there it is there. And again, 10 marks. Yep. Okay, slightly different scale here. So a low partial in this case will only get you 3, and a high partial will get you 7. Okay, so again, have a look there. They have both methods as well, so that's the guide number and that's the minus b. Okay, so hence or otherwise. So this is nice, the way they've done this. So hence basically means using your previous answer. Okay, so that's a nice hint that this is going to be a quadratic. Okay, now again, it's got that structure that it's going to be a quadratic, but the hence kind of hammers it home that it's going to be a quadratic. Okay, so I've got 3 to the power of 2m plus 1 equals 35 minus 8 times 3 to the m. Okay, I think it's going to be a quadratic, in which case if I'm going to solve it, I need equals 0. So I'm going to move this over, and I'm going to move this over. Yeah? I'm going to move them over. So then I've got my quadratic, well, nearly have my quadratic structure. So 3 to the 2m plus 1 plus 8 times 3 to the m minus 35. And now I've got nothing left on the right. I'm going to just manipulate this one. So it's going to be 3 to the 2m times 3 to the 1. And the rest I'm just copying down. Bring the 3 to the front and then split up these two. Keep the letter in and the number out. So it's 3 to the 2m, so it's 3 times 3 to the m and then the 2 outside. 8 times 3 to the m minus 35 equals 0. So we do our lets. 3 to the m equal y, which turns this, oh sorry, come on. Sorry, give me 1 second. Just checking I hadn't burnt the dinner. Right, so we go with the y. So we go 3y squared plus 8y minus 35 equals 0. Now, the fact that this is a hence question, I reckon that's the exact quadratic we just solved up above. 3y squared plus 8y minus... Look. Now, up here it's x's and down here it's y's, but it's the exact same. Which means I don't have to do any of this again. I have the two answers. So there are my two answers. 7 over 3 and minus 5. So y equals 7 over 3 and y equals minus 5. And I got that from, was it part 1 or part A? Part 1. Okay, that's kind of the hence thing. So it's then giving you a hint it's a quadratic, and then also you've got the answer to the quadratic. Okay, so now I need to bring my, I might go back up a bit actually. I need to bring my let back in. So my let was 3 to the m, and 3 to the m equals the first answer, which is 7 over 3, and then 3 to the m is minus 5. Okay. So the variables are in the powers, which means I can't solve using indices, so I need to switch to logs. So it's log to the base 3 of 7 over 3 equals m. And then here it's log to the base 3 of minus 5 equals m. Now, the left-hand side of both of the equations, as in this bit here and this bit here, you can type into your calculator. So log to the base 3 of 7 over 3 is 0.77. Okay, I'm just going to do 4. I don't know what. I'm going to go back to the question in a minute because I don't know what way they want the answer. And then this one, if you type it in, okay, hopefully. Okay, we're going to reject that one because the argument is negative. Okay, so let's go back just to get an idea of the answer. I don't know how many decimal places. So give your answer. So give your answer in the form log to the base 3 of P minus Q. Oh, tricky. Okay, hang on now, watch. I'm just going to try and keep it on the thing. Right, so turns out we don't need this. Now, if I was in an exam, I wouldn't rub it out. I'd just cross it out because we don't need it. They don't. I thought it was going to say like to 3 decimal places. It didn't. Right, look. This here is a division, and a division turns into a subtraction. So log to the base 3 of 7 minus log to the base 3 of 3. Yeah? And log to the base 3 of 7 minus log to the base 3 of 3, don't know if you remember this, is 1. And now if you compare this here, come on, where's my circle? There you go. So if you compare that to that, log to the base 3 of a number minus another number, and then look, it says P and Q are going to be natural, and my P and Q are 7 and 1. So I think that looks correct to me. Hopefully, yeah. So another 10 marks there. Again with, we've got mid partials here as well. So low partial is 8, mid partial is 5, high partial is 8, and then 10 for a fully correct answer. Okay, so that is question 2, and that's another 20 marks. I'm just going to pop that back up the top. Question 2 is another 20 marks. Okay, we will keep going. Question 3. Oh, sorry, formatting went off there. So question 3. The real variables y and x are related by y equals x squared. The equation y equals x squared can be written in the form log to the base 5 of y equals a plus b log to the base 5 of x. Okay. Right, so, find the value of a and b. So y equals 5x squared, and then log to the base 5 of y equals a plus b log to the base 5 of x. Okay, so at a glance, this is an example of a question where we have all these skills and we're trying to apply them. I have no idea how to do this, okay? So I'm going to tell you what I do see, so that hopefully you can follow like my problem solving logic eventually, if I'm right. Anyway, so what I see is 2 equations. One over here that has a y and an x, which means it's not solvable because there are 2 variables. And then another one over here, has how many variables? Like about 1 million? 4, but you know what I mean. Too many. So I'm going to attempt to reduce the variables by subbing this in here. Yeah? Okay, let's try that. So that will give me log to the base 5 of 5x squared. Okay, and that equals a plus log to the base 5 of x. Now, this yoke on the left, so that is log to the base 5, and then it's 5 times x squared, isn't it? So, you know the way there's that rule where you can move the square, I'm kind of talking to myself as well. You move the square from here to here. You can only do that if it's like log to the base 5 of 5x squared. Sorry, I did write what I just said. It's just not coming up there. So if it was like this, then the square belongs to the entire argument, in which case you can move it to the front and apply that law. But here, that's not the case. The square doesn't apply to the entire... Oh, how am I going to get rid of that? No, sorry. The square is only on the x. So I'm wondering, do we go down the multiplication route? Do you know what I mean? So I'm just going to have a look at the law for a sec and see, can I make it apply here? Where's my thing here? Yeah, so see this? So if I've log to the base and these two are multiplied, I can turn that into a plus. Okay, and I think that it looks like that law applies here. Where was I? Exams. Okay. So I want that go away. Go away. Okay. So that is log to the base 5 of 5 plus log to the base 5 of x squared. Yeah? Sorry, that equals a plus log to the base 5 of x is a plus log to the base 5 of x. Okay, so the right hand side is just, I'm just copying it. There's not really much manipulation I can do on that right hand side. Oh, I've also missed a b. Sorry, there's a b here. B. Okay, so this one is easy. It's just 1. Now, this second one here, I can now bring that to the front because the entire argument is squared. So I can make it 2 log to the base 5 of x equals a plus b log. Oh, it's done. Can you see? So the left-hand side and the right-hand side are the same, except on the left-hand side, I've figured out the numbers. So hang on, let me change the order. So the right-hand side is a plus b log to the base 5 of x. Yeah? And the left-hand side is, I didn't have to, look, it's done. 1 plus 2 log to the base 5 of x. So this is this, and this is this. And then everything else matches. So there's the plus and the plus and the log to the base 5 of x and the log to the base 5 of x. So I've done it. So A is 1 and B is 2. Yeah? It's a nice question. Yeah, so anyway, I just kind of wanted to sort of wing it there in the hopes that I'd be able to show you kind of why I did what I did. And because it isn't like a really fine art, and I don't always look at the questions and go, oh my god, I know exactly what to do. Sometimes you just have to do your best with what you've got. So we know that that's not solvable, and we know that that's not solvable. So normally when that happens, you have to kind of combine them in some way. So that's what I started to do. And it turned out I didn't have to do anything with the right hand side. Yeah. You can let me know if you have any questions. Where am I? Oh, there. Did I get it right? A is 1, B is 2. So 5 marks. I would imagine that particular year that was found particularly difficult because 5 is not a lot of marks for that. So yeah, and there's loads of partials for a 5 mark question. Okay, so this is this. Am I in the second half of question? Yeah, so this is the second half of question 3. That one was only worth 5. Right, let's have a look at this one. Hence or otherwise. Oh, hence again. Okay, hence or otherwise. So that means something we learned up above might be of use here. Hence or otherwise, find the real values of y for which. Okay, I'm just going to write this down. Log to the base 5 of y equals 2 plus log to the base 5 of 126 over 25x minus 1. Yeah? I am just going to write down, sorry, I'm going to just write this down. So we had y equals 5x squared can be written in the form log to the base 5 of y plus, log to the base 5 of y equals a plus b log to the base 5 of x. And then I figured that out, so it's log to the base 5 of y equals 1 plus 2 log to the base 5 of x. Sorry, So I was just writing that there. That's because it says hence or otherwise. I feel like this might help. Okay, so it's definitely not identical because we don't, this second part obviously has a lot more to it. And here, that number is a 1 now, whereas previously it was bigger. Okay, so can we change, this, yeah, into this? So that would satisfy the hence thing because I'm using my answer from the previous one. And log to the base 5 of y is 1 plus 2 log to the base 5 of x. And it would also eliminate variables, as in if I put this in here now, 1 plus 2 log to the base 5 of x equals 2 plus log to the base 5 of 126 over 25 x minus 1. What that has done is given me an equation that only has x's in it. So that's helpful, I think. So let's gather our logs. So 2 log to the base 5 of x. And then I'm going to bring this over. So I'm going to do minus log to the base 5. Blah, 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 blah. Yeah? So then when it comes over here, it's going to be minus. I'm going to have to go down. Sorry. So 2 log to the base 5 of x minus log to the base 5 of 126 over 25 x minus 1. Yeah? And that equals, the 2 is already here on the right hand side. And then I'm going to bring this 1 over like that. So I get minus 1. Okay, so I think, so I don't have the 2 out in front. I think if we bring this here and make it a square, so apply, I can't remember what law that is, but log to the base 5 of x squared minus log to the base 5 of 126 over 25x minus 1 equals 2. Oh no, sorry, I can do that. Equals 1. Yeah? So just check the laws again. The minus in between, I think you divide the powers, is that right? Yeah, look. So there's log base number minus log base number, and the bases match, becomes a division. So log base number minus log base number, and the bases match, I can definitely do that. Okay, so I get log to the base 5 of x squared over 126 over 25x minus 1 equals 1. It's not pretty. So this is a log where the argument is unknown, which means I need to switch to indices. So that's 5 to the power of 1 equals x squared over 126 over 25x minus 1. Yeah? Okay. I'm going to multiply by this, 126 over 25x minus 1, because that will cancel that out. And I'm going to multiply this by 126 over 25x minus 1. So I have 5 times 126, my god, I'm 6 saying that, over 25x minus 1. It was 5 to the 1. I just made it 5 because that's the same thing. And that equals x squared. Come on. Okay, so if I multiply, sorry, my iPad's dying. If I multiply the 5 into that bracket, Sorry, can't get the thing to charge. Okay, so I'm going to multiply the 5 into the bracket like this. So 126 divided by 25, sorry, 126 over 25 multiplied by 5 is 126 over 5x. Then 5 by minus 1 is minus 5 equals x squared. The fact, that it has an x squared means it's going to be a quadratic, and for quadratics I need equals 0. So this is a plus. I'm going to do minus 126 over 5x and minus 126 over 5x. And then I'm going to do plus 5 and plus 5. So I have x squared minus, sorry, I've written that wrong, 126 over 5x minus 126 over 5x plus 5, and there's nothing on the other side. And because of this, I'm going to multiply across by 5. So multiply this by 5, multiply this by 5, and multiply this by 5. And I get 5x squared, these cancel, minus 126x plus 25 equals 0. Guide number is 5 times 25, which is 125. Oh, I'm going to get it straight away. It's going to be 1 by 125, isn't it? So that's what I'm going to use because that's what I'm trying to get. And it's going to be a minus and a minus and a minus. So 5x squared minus 125x minus 1x plus 25 equals 0. Same as we did before. 5x is going to be the common factor, which we will divide by. So that gives me x minus 25. Yep. And then green, I think I need minus 1. So divide by minus 1. The two minuses there in the first, the two minuses here. Yeah. Give me a plus, so that's just going to be an x. And then here, the signs are different, so that's going to give me minus, and 25 divided by 1 is 25. So my brackets match. Yeah? Sorry, I'm going to take this up here a bit. So I get x minus 25, which is the matching bracket, and 5x minus 1. Yeah? And then x minus 25 equals 0, 5x minus 1 equals 0, plus the 25 plus the 25. So x equals 25, and then plus the 1 plus the 1. So 5x equals 1, and then divided by 5, and x equals a fifth. Yeah? Another lovely question. Find the real values, so plural, of y for which that is the case. So we don't reject anything. Both form our answers. So x equals 25 and x equals a fifth. So x equals 25, x equals a fifth. What are they doing there? Are they verifying? Oh, they're just subbing back in. Did it ask us to do that? Answer otherwise, find the real values. No, we did that. Okay, so there is the solution. Again, worth 10 marks, like a lot of these. I'll just pop it there. And that is question 3. Yep. So what's that? 15 for question 3. Okay. Yeah, so you can pause the video if you need to look at the solutions or anything like that and check against yours. Okay, so given log to the base a of 2 is p and log to the base a of 3 is q, where a is greater than 0, write each of the following in terms of p and q. Okay, so the first part, I mean, this seems okay. This is a division, isn't it? Come on. Yep. And a division turns into a subtraction. So we get log to the base a of 8 minus log to the base a of 3. Yeah? Now we need to write this in terms of p and q. And p is log to the base a of 2 and q is log to the base a of 3. So this is q. So that one's done. I don't need to do any more. It's just q. Now the other one, you're going to have to turn into, I need a 2, right? So if we go like this, log to the base a and turn 8 into 2 cubed. Sorry, I didn't need that bracket. Turn 8 into 2 cubed. Yeah? And then if you bring the 3 to the front, you get 3 log to the base a of 2 minus log to the base a of 3. So now this one is p. See what I mean? So then it becomes 3p minus q. And that's that one. Yep, 3p minus q. 5 marks for that one. And then this one. So I'm going to go similar because it's still a division. So log to the base a of 9a squared minus log to the base a of 16. Now we have the same problem here we had in the last one. It isn't the entire argument being squared, it's only the a. So we can't bring the power to the front, but we can treat this as a multiplication. So we can go log to the base a of 9 plus log to the base a of a squared minus log to the base a of 16. Yeah, so I can split that up into the multiplication. This multiplication becomes a plus. Yeah, now it's all 3's and 2's I need. See from the previous one, right? So I need to write these in 3's and 2's. So the 9 can be written as 3 squared. Now this one, this power is on the entire argument, so it can come to the front. So it's 2 log to the base a of a, and then log to the base a, and we need to turn into the 16 into either a 2 or a 3. It can't be a 3, but it can be a 2 to the 4. Yeah? Then bring all these powers to the front. So bring this one to the front, and bring this one to the front. So I get 2 log to the base a of 3 plus 2 log to the base a of a minus 4 log to the base a of 2. Now, can't remember which was which. Log to the base a of 3 was that one, so that's q. So that is 2q. Now this one is 2 times 1. Do you remember that? When the base and the argument match, it's just a 1. Like log to the base 3 of 3, log to the base 5 of 5, so that's just a 1. And then minus 4, so log to the base a of 2 must be p. Yeah, log to the base a of 2 is p, so that's 4p. So that gives me 2q plus 2 minus 4p, I think. It doesn't want to finish the p. There you go. And that is right for 5 marks. There you go. It's done now. So 2q plus 2 minus 4p. Yeah, that's right. So that's 10 marks for 10 marks for question 4. And then question 5 was always going to be your proof or construction. So I went with a proof. So prove by contradiction that the square root of 2 is not a rational number. So I'm going to go through this as if I'm in an exam. I've already taught it to you. You have these proofs. So we assume the contradiction. So we assume the square root of 2 is irrational, and therefore the square root of 2 can be written as a over b, where a and b are integers, and the highest common factor of, the highest common factor of a and b is 1. Yeah? Okay. So we take the square root of 2 equals a over b, and we square both sides. So that gives us 2 equals a squared over b squared. I'm going to multiply across by b squared to cancel this out, and multiply by b squared. So I get 2b squared equals a squared. That tells us that a squared is divisible by 2. And if a squared is divisible by 2, then a is divisible by 2. So that gives us Yeah? So the fact that a squared was equal to 2 times b squared, that meant that a squared was divisible by 2. And any square number that's divisible by 2, the actual number is divisible by 2. That makes sense. So, for example, if 64 is divisible by 2, which it is, so 64 is your squared number, then the square root of that, the 8, must also be divisible by 2. Yeah, so that's what I'm saying. Here I'm saying the square number is divisible by 2, and then down here I'm saying the number itself is divisible by 2. Yeah? Now I sub that back in, so I get 2b squared equals 2k to b squared. Okay, that's subbing this back in up here. So that gives me 2b squared equals 4k squared. Yeah, the 2 is outside, so we need to square the 2, square the k, so we get 4k squared. I want to isolate b this time, so divide across by 2, and I get b squared equals 2k squared. Again, this implies that b squared is divisible by 2, and if b squared is divisible by 2, then b is divisible by 2. So our assumption was that root 2 was rational, which was that it is equal to a over b, and we said a and b had to be integers, and the highest common factor of a and b had to be 1. But the highest common factor of a and b is actually 2. Okay, because a up here, a is divisible by 2, and then down here, b is divisible by 2. So that means if they're both divisible by 2, then the highest common factor has to be 2. Therefore, square root of 2 is not rational, which is what we were asked to prove. Okay, so that's literally word for word the one I gave you in class. So it's here. I mean, everyone proves these slightly differently. They use even rather than divisible by 2, but same thing. Being even and divisible by 2 is the same thing. Okay, so the thing is there, and you can see how far you got, whether you got a low, a mid, a high, or hopefully full marks. So that was also worth 10. So what's that? 60, 75 it's going to be out of. So you can double check your mark. Okay.